Hello. I want to tell you about how we can do two-way ANOVA with interactions using SAS. The task we're going to take up will be the adult 1 dataset. The adult 1 dataset has 32,000 plus records of adults who are either married, divorced, or unmarried, and also we have education data on these adults, whether they've been to high school, college, master's degree or associate's degree, and so on. And so we want to try and see if there's any relationship between education, marital status, and capital gain. So before we start creating the ANOVA, I would like to make sure the data set only has records where the capital gain is not zero. Okay, anything above zero we'll take it, and because there are many records where the capital gain is shown as zero, and it could be either missing or it could be genuinely zero, but we will not consider that for our analysis. And also, next thing we want to make sure is that the education level right now is not a variable, but we will create it using another variable called education num. Education num is a numeric type data, and it essentially represents the level of education each adult has, and it goes from, I believe, 7 to 16. So I will pick anything that's above 10 to be high education level, anything that's below 10 to be below or less than or equals 10 as not high education level. And also we want to the marital status column itself has many different values, and rather than using all those values, I'll just collapse them into just two values, either married or not married. So if it is 0 means it's not married, and 1 means married. And I did peek into the data marital status and found that all the values that begin with married happens to be married adult. So I use a function called index that will search inside marital status column for a string married, M capital, and then it'll result in whatever the position this word appears inside marital status. Now I found that if this word was not found, index would return 0, and if this word was found, index would return 1. Okay, because 1 is the first position, is the index of the position where this word was found. So then once we got that, then we can go ahead and run the two-way ANOVA, and where we want to describe capital gain as a function of education level, married or not, and also an interaction between education level and married. So let me show you what the SAS model looks like. Okay, so this is our original data set, adult, and as you can see, education, we have a string representation of education as well as a numeric representation of education. And so what I do is I would collapse all the numbers that are about 10 as high and anything 10 or below as low. And also marital status, the word married, if it is the beginning of the value, then I want to pick that. If it is not at the beginning of the value of the string, I don't pick that. So like for example, if it says never dash married, it's lowercase m, and if it is at the beginning of the word, then it's always uppercase M. So I use I look for all the entries that begin with married, and then use that as 1. And if it does not begin with married, then it becomes 0. Now let's take a look at the query that I used to build my filter my data set. So this is the original list of columns, of which I picked marital status and education just to check that I'm getting the right numbers, and this is also coming directly from the original data set. I have two calculated, and so let's go to the education level. So I double click on that, and here we have let's go to edit. So this function, what it looks is IFC. We've seen this before. If C, so it will return a character type value. So if the if function says if education number is greater than 10, then return high, and otherwise return not high. That's about it. Okay, and I'm calling it education level, and finish. Okay, and similarly, I can also take a look at the married column that was created, and here what I'm doing is I'm just using an index function. And the function, how did I find out about this function? Well, this function is available under edit computed column dialog box. If you go to the lower half, you have the helper. So click on functions, and I click on categories, and click on character. So character, I believe is the one I'm using. That's a whole bunch of functions here. Now in this we have something called index function. So index function searches a character expression for a string of characters. Okay, so it uses basically two arguments: source, which column you want to use, and what you're looking for. Okay, so the column I want to use is marital status. What I'm looking for is married, and then what it does is it will return it returns if the string is not found, it returns the value 0. So meaning if capital M married is not found, it returns 0. Otherwise, it will return to the position of the first occurrence of the string. Okay, that's what that will work for me. That's why I could use it. And finish. Okay, and so these are the two calculated columns. I also set up a filter. So go to filter, and filter, we have seen this before, and you can set up a filter right here, and simply column name is capital gain, and the operator I'm using is greater than, and 0 is the value. Okay, and once I got this query set up, I run it, and once it's run, I have the result show up here. So this is the result of the query that was run, and so all the marital status values that did not begin with capital M married show as 0 for married column, and as you can tell, all right, and all the education level that was 10 or high, about 10 got high, and anything 10 or lower got not high, and I got the capital gain column. Okay, now this is the capital gain is a numeric type, and married is 0, 1, and although it's numeric, it can be considered simply a nominal type, whether somebody is married or not. And then I'm going to use ANOVA to see if there is any result, any interaction of married, education, and capital. So let's go back here. Now to do that, I use a linear model, and let me go ahead and walk you through the linear model. So let me delete what I have already done, and then I'll go to Analyze, ANOVA. Under ANOVA, we want to choose linear models. Since we have two independent variables, I use the two-way ANOVA, which is available under linear model. So here we have here's where you specify the model, and if you remember, I was talking about if you want to say education level and married should be able to determine or describe capital gain. So the capital gain is a dependent variable, so it's select capital gain and assign it to dependent variable, and married goes to the classification variable. Okay, and education level also goes to classification variable. Okay, alright, so that's two-way ANOVA. And then in the model I have to say what my effects are going to be. The main effects will be married and education level. Then I also want to have a kind of a interaction effect, so I highlight both these variables and click cross. So this will interact, it will set up an interaction between married and education level. Okay, and then we'll go to model options. I believe there's no change here. Advanced options, I'm not going to mess with any of this. And post hoc tests, let's say arithmetic. Okay, we'll run the ANOVA and see what it looks like. We can also add additional interaction plot that is used, that's described in your notes. And let's not worry about any predictions, and let's go ahead and run this. Okay, here we have the results of the ANOVA, and so it's a GLM procedure, general least squares model, general linear model, and the result itself looks good. The null hypothesis that the mean capital gain by groups that are grouped on merit or not, education level, high or low, are not equal. So the null hypothesis was that they were equal. Now your probability is less than 0.05, so we can reject the null hypothesis. Now that's the overall effect. Now we can also look at the individual effect. The individual effect, if you look at it, it says married, it's significant. So between married and married 0 and married 1, they are significantly different mean values for capital gain. Education level also high, not high, there is a significant difference between the two. And also we find the interaction between married and education level is also significant. So it's less than 0.05, so it's 0.02, which is significant, so we would keep that interaction level also. Okay, and as we scroll down to the interaction chart, that's what it looks like. So it's not exactly crossing each other, but overall the education level, if it is high, that's above here, and if it is not high, it's below there. And also the married points seem to have higher, higher distribution or wider distribution of the capital gain versus not married. Okay, and there is sort of an outlier here, could be it's way out there, maybe you need to take a look at that. Anyways, this is how we could do two-way ANOVA using SAS. Thanks.